We are going to review the rectangular coordinate system, which has quite a few definitions, as you can see. Most of these definitions I will be including as we go through this page of notes, but I do want to point out a couple of them before we get into the examples. So first, we want to make sure that you remember that the horizontal number line is called the x-axis, while the vertical number line is called the y-axis. Each point in the system is associated with an ordered pair of real numbers, and if the equation is in terms of x and y, then the points are x, comma, y, and in that order. The first number is the x coordinate, and then the second number is the y coordinate. Now, one of the things you have to be very careful about whenever you are reading a graph or plotting points, you cannot do so unless scale is indicated. And scale shows us the value of each of the vertical or horizontal lines in your coordinate system. And without scale, points cannot be plotted, nor can they be read. The other definition that you need to recall is origin, and that is where the horizontal and vertical axes intersect, and that is at the point 0, 0. And then the last definition we need to go over is quadrants. So our axes divide the coordinate system into 4 infinite regions called quadrants, and I'll be outlining all 4 quadrants so that you can locate the points and identify the quadrants that the points lie in. So let's get into our first example. So we are going to identify quadrants and plot points A, B, and C. But before we can do this, we need to label our x-axis, our y-axis, and also indicate scale. So our x-axis is the horizontal axis, our y-axis is the vertical, and then we need to indicate scale. And scale tells us what each, let's say, line means. So all of these points are pretty close to the origin. A, B, and C are all pretty close to the origin. So I don't have to go very far with my scale, but sometimes you do. Now you do not have to waste time and label each line, but each line could have a value of 1, but instead of squeezing 1, 2, 3 in, I'm going to count off 1, 2, 3, 4, 5, and I'm going to label this as 5. I'm going to go up 5, I'm going to go to the left 5, and I'm going to go down 5 as well. Always label your scale in all 4 directions. And now I'm ready to plot point A. So point A, I'm recognizing that x is 2 and y is 3. And so I'm going to go to the right 2 and up 3, and that is point A. With point B, x is now 3 and y is negative 5. And point C, x is negative 4 and y is negative 2. So that is point C. So now we want to talk about the quadrants. Now there are 4 quadrants, and the first quadrant is in the upper right hand position, and we go counterclockwise. So quadrant 1, quadrant 2, quadrant 3, notice I'm using Roman numerals, and quadrant 4. So that means point A is in quadrant 1, point B down here is in quadrant 4, and point C is in quadrant 3. And so your first question on this video is, what quadrant does the point -4, 6 lie in? Our next exercise, we're going to graph a linear equation by plotting points. Now, we will be graphing equations in other ways this semester, but remember, a lot of times when we're doing our pre-work, this is review, or this is getting you ready for in-class work, getting you ready for your ALEKS homework. So we're going to graph this linear equation by plotting points. So I have a table of values here. So I'm going to choose X, and I'm going to input X in order to figure out what Y is equal to. So Y is set equal to 3X minus 2. So I'm going to let X take on both positive and negative values as well as 0. So I'm going to let X be -2, -1, 0, 1, and 2. And notice I'm staying pretty close to the origin, and that's because my 3 is not very large, and then this -2. 2 is not very large as well. So I have a feeling that most of my points are going to be pretty close to the origin. Now I'm going to start with 0, and this is going to be important, and it's going to lead into our next discussion. So if I let X be 0, then that means Y is equal to 3 times 0 minus 2. But 3 times 0 is 0, and 0 minus 2 gives us -2, and that gives us our first ordered pair, 0, -2. Input, output. When I let X be 1, then I have 3 times 1, which is 3, and 3 minus 2 gives us 1. When I let X be 2, I have 6 minus 2, which is 4. Now I want to go in the negative direction, so I'm going to let X be -1. So 3 times -1 is -3, and -3 minus 2 is going to give me -5. Watch your arithmetic, correct? And then finally, Y equals 3 times -2, which is -6, and -6 minus 2 is going to give me -8. Now, before we plot these points, I do want you to notice that as X is increasing by 1, so X increases by 1, what happens with Y? Y is changing as well. What happens each time? As X is increased by 1, what happens with Y? And I want you to think about that. Okay, so then in order to graph this, we need to do as before. We need to label X, we need to label Y, and we need to also show scale in all 4 directions so that we can actually plot these points. Now notice most of my points are very close to the origin, so I'm not going to go very far. The scale can be a value of 1, so I'm going to go 5 to the right, up to the left, and down. And my first point is -2, -8, -1, -5, 0, -2, 1, 1, and then finally the last point I have is 2, 4. But these are all points that came about because of the X values that I chose. But I could have chosen an infinite amount of X values. X can be anything. So we want to make sure that we are representing the fact that X can be anything. So we need to connect these points, and we need to also indicate that this is going to go on forever. So I'm choosing a straight edge of some sort. And then I'm also showing arrows at each end, and it goes on forever. Now you can label this line. Most of the time when we're working together, it's going to be either in class on a particular problem or on a test. And so often you don't have to label the line because it's obvious that this is the line you're talking about, but if that makes you feel more comfortable to do so, absolutely go ahead. And then we have a final question for your online work in Edpuzzle, and is this line rising, falling, horizontal, or is it vertical?